A ratio is a way of comparing two or more quantities. A ratio says how much one quantity is as compared to another. Hello everyone, this is Rewan Hari presenting Junior Certificate Mathematics lesson, and the topic for today is ratios. Before we can elaborate more on ratios, let us have a look at the lesson objectives. The lesson objectives say simplifying ratios. So we are going to be simplifying ratios. But before we can start simplifying them, let us have a look at the notes that we are having here so that we may have a clear understanding of how ratios work. We use ratios to describe the quantities of different ingredients in a mixture. That is, when we got a mixture, there is a ratio involved in making up that mixture. And we are simply saying we use the ratio to describe those quantities. And then, in addition, a ratio is normally written using whole numbers only in its simplest form. That is, the ratio that's supposed to be written should be simplified. The answer given should be in its simplest form. Let us have a look at what we should be having. Mathematical representation of ratios. The example says, in a certain school, the ratio of boys to girls is 5:4. Represent this using ratio notation. So this is a statement, and we are to represent this statement using the ratio notation. This is how we are supposed to represent this using the ratio notation. In a certain school, the ratio of boys to girls, so it's boys to girls. The ratio of boys to girls is 5:4. The parts which represent boys is 5. So the ratio will be 5:4. This is the ratio of boys to girls. And I want to believe you can see that this is how we represent this mathematically. There is the mathematical notation for ratios, which is this part. This represents the mathematical notations, and our ratio is 5:4. Now, before I go further, let me invite a student who has just joined me here to say something. Maybe got a question that she will want to ask. He'll want to ask rather.
My name is Stefalipe. Thank you, sir. I want to understand the idea and notation of ratios. Can you please give examples of ratios showing how they are written mathematically?
Thank you, Tifo. You want me to give another example where a statement is given and then represent such a statement in mathematical terms using ratios. Example 2 says, there are 2 horses, 4 cows, and 6 goats in a kraal. So this is what we are having. We've got horses, cows, and goats in a kraal. Now, it says represent this information as a ratio of cows to horses to goats. Now, therefore, we must be very careful the way we are going to represent this. The statement is given as horses, cows, goats, but the question says we are to represent the ratio of cows, horses to goats. So we have to start with cows, then horses, then the last goats. So let us represent that in ratio form. So this will be a ratio of cows to horses to goats. Ratio of cows, horses to goats. How many cows do we have here? We got 4 cows. So this will be 4:2. And then how many horses do we have? It says there should be 2 horses. So this is 4:2. And then how many goats do we have? We've got 6 goats. 6. Now the ratio of cows, horses to goats is 4:2:6. Remember, in my objective, I said ratios are always represented as whole numbers simplified. Now, this one is not simplified. We will see as we go further how we simplify ratios.
That's very interesting. But how do you simplify ratios? Please give examples.
Thank you, Tifo. You are saying we should now go on and simplify ratios. That is, I should give examples where ratios are simplified. Let us have a look on the board and then see how ratios are simplified. It says simplification of ratios. The example is here, 20 to 16. Now remember, we are simplifying ratios. So it's a question of how do we simplify ratios. 20 to 16, this is a ratio. Now, how do we simplify this? We look for the highest common factor of 20 and 16. We look for the highest common factor of 20 and 16. Then divide 20 by that highest factor as well as 16. Now, the highest common factor of 20 and 16 is 4. So, 4 into 20 is 5. This will be 5 is 2. And then 4 into 16 is 4. Now, the ratio is 5 is to 4. Not 3, but to 4. 5 is to 4. This is supposed to be 5 is to 4. So this is 5 is to 4. This is simplified now. It's a simplified version of the ratio 20 to 16. And I believe you are now getting there. We may as well look at another example. 24 to 72 to 12. We look for the highest common factor of 24, 72, and 12. Then divide the numbers here by that highest common factor. Now, the highest common factor of 24, 72, and 12 is 12. 12 into 24 is 2. Then remember the ratio notation. 12 into 72 is 6. And then 12 into 12 it's 1. So the ratio is 2 is to 6 is to 1. It is now the simplified version of the ratio 24 is to 72 is to 12. And the simplified version is 2 is to 6 is to 1. Remember, when we simplify ratios, you divide by the highest common factor of the numbers involved within the ratio. This is how we simplify ratios. And I believe you are now in position to simplify ratios given in any form. Let us go for a short break. When we come, we'll continue with our lesson. Welcome back from the short break. Therefore, we are still discussing ratios. I want to give you this opportunity to ask you another question so that we may develop on our topic.
Thank you, sir, for the examples we have just discussed. To understand this topic further, can you please simplify ratios involving the use of different units or fractions?
Thank you. You want me to cover a situation whereby the ratios involve different units and fractions. The example here with me will answer that question. Example says 10 centimeters is to 5 meters. When we look at the units are different. 10 centimeters and then 5 meters. So the ratio here is not simplified. We can't leave the ratio like this. We have to make sure that the units are the same first. So let us make sure that the units are the same. We need to make sure that the units are the same. This will be equals to, we have to change this. This is 10 centimeters. So we have to change the meters here to the centimeters. So this will be 10 centimeters is to 5 meters. How do we change meters to the centimeters? We multiply by 100. So this will be 5 times 100 centimeters. Remember, there are 100 centimeters in a meter. So that's why we are multiplying by 100. We are converting the meters to the centimeters. And to do that, we simply have to multiply by 100. And this will simplify to 10 centimeters is to 500 centimeters. Now we've got centimeters and centimeters. So this, upon simplifying, will be 10 is to 500 because the units are the same. Now 10 is to 500. How do we simplify this? We divide the numbers involved by the highest common factor of the numbers. It's 10 and 500. So the highest common factor is what? Is 10. So divide both sides by 10. This will be 1 is to 5, 0. It's a simplified version of 10 centimeters to 5 meters. The ratio now in a simplified version is 1 is to 15. This is how we simplify ratios involving different units. Make sure that the units are the same before you can start simplifying. Let us look at another example. We've got another example here. 25 grams is to 1 kg. Also, the units are not the same, so we should start by making sure that the units are the same. This is 25 grams, this is the kg, so we have to convert the kgs to the grams. Now this will be 25 grams is to 1 times, how many grams are there in a kg? It's a kilo, so it's 1,000. This will be 1 times 1,000 grams. This now simplifies to 25 grams is to 1,000 grams. The units are now the same. Now because the units are uniform, we now simplify. How do we simplify? First, this will be 25 is to 1,000. Now the next step is to simplify. We divide both sides by the highest common factor of 25 and 1,000. That highest common factor is 25. So 25 into 25 is 1. And then 25 into 1,000, 25 into 100 is 4. And then into 0 is 0. So the ratio is 1 is to 40. This is a simplified ratio of 25 grams to 1 kg. Upon simplifying, it will get 1 is to 40. Remember, you always have to make sure that you convert the units. The units have to be the same before you can start simplifying. Then, after that, look for the highest common factor, then divide all the numbers involved with that highest common factor. Now, you also stated in your question that I should also include examples which involves fractions. Of course, ratios can be represented as fractions and then simplified. Let us have this example. 3 over 4 is to 2 over 3. This is to 1 over 2. These are fractions. 3 over 4 to 2 over 3 to 1 over 2. These are fractions. So how do we simplify this? We will multiply by the lowest common multiple of 4, 3, and 2. These are the denominators. So we multiply by the lowest common multiple of 4, 3, and 2. That lowest common multiple is 12. So we will have 3 divided by 4 times 12 is to 2 over 3 times 12 is to 1 over 2 times 12. Times 12, not 1. So we have managed to multiply by the lowest common multiple of 4, 3, and 2, which is 12. We now simplify. 4 into 4 once. 4 into 12 is 3. And then 3 into 3 once. 3 into 12 is 4. And then 2 into 2 once. 2 into 12 is 6. This will then be 3 times 3, it's 9, is to 2 times 4, it's 8, and then 1 times 6, this will give us 6. So the ratio 3 over 4 to 2 over 3 to 1 over 2 simplifies to 9 is to 8 is to 6. This is how we simplify ratios involving fractions. Let us have a look at another example. Let us have a look at another example involving fractions. We can have 1 over 5 is to 3 over 10 is to 3 over 10. 3 over 10, which is to 3 over 5. We've got 5, 10, and 5. We now have to look for the lowest common multiple of 5, 10, and 5. That lowest common multiple is 10. So 10 is the lowest common multiple of 5, 10, and 5. So we will multiply throughout by that lowest common multiple. So this will simplify to 1 over 5 multiplied by 10 is to 3 over 10 multiplied by 10, not is to 10, but multiplying by 10. We need to be multiplied by 10. Okay. Times 10 is to 3 over 5 times 10. This simplifies to 5 here once, 5 into 10, 2. This is supposed to be 4, not 3 over 9, it's supposed to be 4. This is supposed to be 3 over 10 times 10, not 3 over 4, but 3 over 10 times 10, because it's from here. So it's 3 over 10 times 10. And then 10 here, once, 10 into 10, 1. 5 here once, 5 into 10 is 2. Now we got 1 times 2 is 2, is 2. 3 times 1 is 3. And then 3 times 2 is 6. This has been simplified. When we try to check if at all there is any common factor which can go into 2, 3, and 6, there is none. So this has been simplified. We now write our answer as 2 is to 3 is to 6. Now note, when we are given fractions involving ratios, what we simply have to do is to multiply by the lowest common multiple of the denominators and then simplify. Let us go for a short break. When we come, we'll continue with our lesson. Welcome back from the short break. I want to believe learners who back home you have understood how we simplify ratios. Let me find once more from Tifo what else he wants us to cover here.
Thank you, sir. I'm really enjoying this lesson. But what if ratios are given as decimals? How do you simplify them?
Thank you, Tifo. You are saying we should now deal with situations where ratios are given in decimal form. The example here involves ratios given in decimal form. Let us simplify them. By the end of this lesson, we should have understood how to deal with ratios involving decimals. This is the example. 1.2 is to 3.4. We now have to simplify this. These are decimals. These are given as decimals. We now have to simplify this to ratios. This will be equals to, we are going to multiply by a number such that every number which is in the form of a ratio here will be a whole number. Now when we check 1.2 and 3.4, to make 1.2 a whole number, we can multiply by 10. The same thing applies to 3.4. We have to multiply by 10 throughout. So when we multiply by 10, this will be 1.2 times 10 is to 3.4 times 10. And this will be 12 is to 34. 12 is to 34. We now check, is the ratio simplified? It is not. We can see that there's a factor which can go into 12 and 34, and we need to divide by that factor. If we start by dividing by 2, we can say 2 into 6, into 12 rather, is 6. 2 into 34, 2 into 3 first is 1, and then into 14 is 7. So the ratio is 6 is to 17. This is how we simplify ratios involving decimals. We can also look at another example to make you understand further. 4 is to 3.5 is to 5.5. There are now 3 parts of ratios involved, and we now want to simplify this ratio. How do we simplify it? This is a whole number, is okay, but this is 3.5, this is 5.5. So these are decimals. We need to make them whole numbers before we can simplify. Remember, when you multiply any number here by, say, a multiple of 10, you have to make sure that everything is multiplied by that number. So this will be 4 times 10 is to 3.5 times 10, which is to 5.5 times 10. So we are multiplied by 10 here to make 3.5 and 5.5 whole numbers. This then will be 4 times 10, it's 40, is to 3.5 times 10 is 35, and then 5.5 times 10 is 55. This is 55. We now check, is our ratio simplified? It is not. We can see that there's a factor which can go into 40, 35 and 55, and that factor is 5. 5 into 40, it's 8, so this will be 8 is 2. 5 into 35, it's 7, and then 5 into 55, it's 11. So we got 8 is to 7 is to 11. We have to check if at all there's any other number which can go into 8, 7 and 11. And upon checking, there is no other factor which can go into 8, 7 and 11. So the ratio here is simplified. This is the answer. 8 is to 7 is to 11. This is how we simplify ratios. Another example can be this one. 0.08 is to 0.2 is to 1. When we look at this example, this is written correct to 2 decimal places, this is written correct to 1, and this is a whole number. So we have to make sure that we simplify this. How do we simplify this? We are guided by the number with the highest number of decimal places. Here, when we check 0.08, 2 decimal places, 0.21, this is a whole number. So the number with the highest number of decimal places is 0.8. To make this 0.8 a whole 0.08 a whole number, we have to multiply it by 100. So this will be 0.08 times 100 is 2. Because we have multiplied by 100 here to make this a whole number, we have to multiply everything here by 100. So this will be 0.08 times 100 is 2. 0.2 times 100 times, not times but 2, this is 100 is 2, 1 times 100. This will be 0.08 times 100, it's 8. And then 8 is 2, 0.2 times 100, it's 2, 0 is 20. You move the point twice to the right. And then 1 times 100, it's 100. The ratio now is 8 is to 20 is to 100. You check, is this simplified? Do we still have any other factor which can go into 8, 20 and 100? There is. There is a factor which can go into 8, 20 and 100. And that factor is 4. So 4 into 8 is 2. 4 into 20 is 5. And then 4 into 100 is 25. The ratio is 2 is to 5 is to 25. This simply says when you simplify the ratio 0.08 is to 0.2 is to 1. The simplified version for this will be 2 is to 5 is to 25. This is how we simplify ratios. Every time, make sure that you convert the decimals into whole numbers. We can as well have the last example where we have 0.2 is to 0.01. This is another example. 0.2 is to 0.01. This is, to make this to a whole number, you have to multiply by 10. But then the highest number of decimal places are seen here, where we've got 0.01. So we have to multiply by 100. Now, this will be 0.2 times 100 is to 0.01 times 100. And then this will simply be 20 is to 0.01 times 100 is to 1. So this also simplifies to 20 is to 1. This is how we simplify ratios involving decimals. We have now come to the end of this lesson. Please keep revising ratios till we meet again in the next lesson. Thank you.